at page 1. This is a review of things that you guys learned in middle school. Okay, so when we talk about the ratio of something, what's another term for ratio? Or what's the definition of a ratio? Any ideas? Do you guys remember? Okay, good. We're eventually going to talk about it as a scale factor as well. Good. But ratio is, if you're thinking about what we're doing here, eventually you guys have the original mean and then your final mean. And this is done a lot, like when you think about blowing up a billboard, somebody has an original sketch of the commercial or the ad, and then they have to blow it up to the size of the billboard. So proportioning it out so that it makes sense with the scale and scope of the project itself. So a ratio is really a comparison of two units, and it can be expressed in a couple ways. So you guys are probably used to your ratios either being said like your scale factor written with a colon sign in between, so A to B, okay, or as a fraction, A over B. So your scale factor can be written as such. The Unit 4 packet is under modules. Thank you, Cody. So if you guys, by the way, it's always posted for the particular week. If you need to print something, it's posted under modules in Canvas. Okay, so for example, the ratio of 8 to 12 is written as 8 over 12. Or I'd like you guys to reduce all your ratios so that it is in reduced, simplified fraction form. So in this case, 2/3. Okay, so ratio of x to y, again, can either be written as x to y like that or x over y. In that little side note, it does mention when you guys have variables that it becomes what we call a rational expression, which just means it's a ratio of two things. And with rational functions, if we start talking about it in terms of Algebra 2 trig, when you guys study it, you'll think of like, well, all the rules that you can't break as a fraction, or for example, like the bottom of a fraction can never be equal to 0. So in this case, x over y is fine so long as y is not 0, because we can't divide by a 0. Okay, so geometrically, what we're going to start to do is compare shapes and talk about something called similarity. Whether two objects are similar is whether they're proportional to each other. Okay, so in this case, we're just working with ratios. Find the ratio of OI to ZD. And remember, that is just writing it in terms of a fraction. So I would write OI first. And when I say first, that means that's going to go on the top of your fraction numerator. Over the bottom would be ZD, which in this case is 2B plus 28. Now, this is just an exercise in making sure that you guys reduce your fractions as well. So in the bottom, you guys have a binomial. That binomial you guys can factor out at 2. So we have 14 over 2 times b plus 14. Okay, and then we look to see if we can reduce anything. And it looks like the 2 and the 14, you can reduce those two. 14 is divided by, when you divide that by 2, you guys get 7 on top. And your final answer would be 7 over b plus 14. So fractions, you're going to think of all the ways that you could reduce fractions when you were in pre-algebra and algebra 1, including binomial expressions like that. Okay, so for part B, it says find the ratio of the measure of the smallest angle to the measure of the largest angle in this trapezoid. Okay, we're going to talk about the measures of the angles of a trapezoid. The first thing that we'll do is I'm going to talk to you guys briefly about this because we haven't focused on trapezoids yet. But when we're looking at a trapezoid, one of the definitions of a property of the trapezoid is you have one set of parallel lines. So if that's the case, then if I view this as my transversal, what's the measure of this angle measure that I just circled on top? What do you guys think? What's that angle measure? And think of it in terms of parallel lines. You have one set of parallel lines, good. And then you have the angle on the bottom is 70 and the top is same side interior angles to it, very good. It should be 110 degrees, right? Because they should be supplementary to each other. So 110, 70. And then if you guys can give me the angle measured down on the bottom, this time over here, because it did say find the ratio of the smallest to the largest. So I'm just trying to figure out what all the missing angle measures are first. Okay, good. So same thing, except your transversal is going in the opposite direction, but you still have same side interior angles. So that angle plus the 120 should be 180. So this is 60 degrees. So if they want a ratio of the smallest angle of the trapezoid to the largest, I would say the smallest is 60, the largest is 120. So if I reduce that ratio, I get a ratio of 1 to 2. Okay. Pretty straightforward so far. If I have a description of objects, and so this is true for you guys as well, we're not going to first think of doing our mean with centimeters and then switching all of a sudden to meters or to inches. We're going to maintain the same units. So when we compare two objects, we want to make sure we're consistent with our measurements of units. In the case of the example below, you guys have a poster is 2 meters long and 52 centimeters wide. Why is it incorrect if I find the ratio of the width to the length that I do 52 over 2? Why would that be incorrect? For me to say the ratio of the width would be 52 to 2. Any ideas? And I usually would, good. Okay, so actually when you're reading the ratio of blank to blank, the width would come first and then the length. So the width would go on top and then the length. So the order is not correct. Or sorry, the order is fine in which I wrote that. But if you notice, kind of tricky, but the top is centimeters and the bottom is meters. So I can't possibly compare the magnitude of those two unless they're in the same units of measure. So what we're going to do is convert my meters into centimeters. So 52 centimeters to 2 times 100 would be 200 centimeters. And then if I reduce that, they're both reducible by 4. So 13 over 50. Okay, so comparison would be 13 to 50. Okay, so other extended proportions are just proportions in which you guys are comparing different ratios. So if you look at the bottom here where they just say, what if you guys had C to D to E? Well, we wouldn't write that as a fraction. We would leave it as a ratio as such, but then understand that it means that I'm comparing C to D as well as comparing D to E, and then finally C to E. So there's 3 different interpretations of that extended ratio. So when I'm looking at reducing something like that, which I'm not going to rewrite as a fraction, the ratio 8 to 10 to 4 can be reduced by what common factor, you guys? What common factor can be 8, 10, and 4 be reduced by? Okay, so if it's all reducible by 2, which is what you guys are writing out, then I would just rewrite this as 4 to 5 to 2. I just basically divided everything through by 2. Okay, divide out by the common factor. And so for our purposes, one common question for geometry might be that they give you guys the measures of an angle are proportional to each other in some fashion. So in this case, there's 3 angles of a triangle are in the ratio 1 to 2 to 6. Find the measures of each angle. So one mistake that I oftentimes see students do is they say, okay, the measures are 1 plus 2 plus 6. Well, think about that logically. 1 plus, don't write that out, 1 plus 2 plus 6. Does that make sense with the fact that you have the angles of the measures of a triangle should equal what? What should they add up to? 180. Okay, we're saying that it's proportional to that, the ratio that's presented there. And so what we need to figure out is, if you look at this division by 2, we want to figure out what that factor is that's common to all of 3 angle measures. And so yes, very good. So what you would do is go from 1 to 2 to 6 to say that there is a common factor of x that we're trying to figure out. Okay, so it could be that it's 2, it could be that it's 3. We're trying to figure out what that value is. And Richard, I'll come back to your question. Okay, so 1x plus 2x plus 6x would get you guys 9x is equal to 180. Okay, if you guys divide out the 9, you get x equals 20. And it does say find the measures of each one of those angles. So if I were to plug 20 back into each one of these expressions, I would get one of the angles is 20 degrees. Okay, the other one would be 40. What's the last angle measure equal to? Okay, so you guys wrote 120. That makes sense because 20 times 6 is 120. So all I'm doing is plugging it back into each one of these. And then that makes sense because do these measures add up to 180? Do these all add up to 180? Yes. Okay, so those are proportional to each other with that ratio of 1 to 2 to 6, and they add up to 180 degrees. Now, Richard had a question back on the first example. Richard, your question was, where did I get 52? 52 was given to me. They wanted the ratio of the width. So the width is 52 centimeters. I wrote that on top to the length. So over the length, which is 2 meters. 2 meters is the same thing. If I want to convert it so that it's the same units of measure, there is, if you didn't know that, then for every 1 meter is equivalent to 100 centimeters. So 2 meters would be 200 centimeters. So I basically converted both top and bottom to be the same units. They have to be the same units of measure. Does that make sense? Oh, okay, he didn't see the units. All right, you guys, so down, or not down for you guys, but on the next page, I'm going to go to the next page. Okay, when we look at a ratio, there's no equations involved, okay? So when we look at a proportion is going to involve an equation with ratios in it. Or fractions. Okay, so when we're, what most common to you guys probably is this. Okay, so this is considered a proportion. If I just have one side of it, it's a ratio. This is another ratio. So 2 ratios set equal to each other, equations with ratios. So that's a proportion. Okay, so when we're, it's just some vocabs, some vocabulary words here. The A and the D are in the extreme most part of your proportion. So that those 2 values are called the extreme values. So A and D are the extreme values. Go ahead and circle A and D. The circle is your extremes. They're referred to as your extremes. Okay, there was a property that you guys learned before called the extreme, the means extreme property. So the extremes are, again, the values that are furthest away from each other, the A and the D in a proportion. Okay, so then the other values in between that, the B and the C, are what we call the means. Okay, so I'm going to put a box around B and C in this and say that these are going to be your means. And sometimes your teacher in the future might say the means extreme property, and then others might informally refer to it as something else. And so we'll see if you guys remember what this is in reference to. So the means extreme property is, how many of you guys remember doing this? Okay, me just circling that. Do you guys remember doing that? Yeah, the butterfly, some people call it butterfly method. Some people call it cross product. Some people call it formally the means extreme property. So if you guys look at A says AD equals BC, most commonly known as cross multiplying, but formally known as means extremes property. And yes, many of you guys know it as butterfly or cross multiply. And what we say is that that expression is true. It's equivalent to what you guys have written above. And so when we're looking at whether a proportion is equivalent to the original, what I do in my head is if notice like that for part B, that what happens is that they switch the position of the B and the C. Okay, B was on the bottom before, and now B's on top in part B. Okay, so they switch your means, and the question is it equivalent? And the way that you guys check is if you guys were to cross multiply this, do you guys end up with the same as A? You guys end up with the same expression if you cross multiply, even if you switch the means. Okay, and the answer is yes. AD equals BC is still the same means extreme as the problem or the original proportion above. So long story short, you guys can switch the means and you would still get an equivalent proportion. And so here you guys can say the means can be exchanged or interchanged. And if we think about it with the extremes or switching the A and the D, we can also switch the A and the D and we'd still end up with the same product. So I would say this means can be interchanged as well as the extremes. And this is all just to say that if that were to happen, you guys would still end up with an equivalent proportion. That proportion would still be the same. Okay, now look at part C. Okay, if you guys look at part C, I want you guys to mentally do the cross product in your head or cross multiply in your head. Do you guys still get the same answer if you cross multiply that expression or that proportion for C? Cross multiply that in your head, do you guys get the same expression as A? Okay, we still do. What's the difference though? What's the difference between what you guys had originally and then what you have here? What did they do? What did they do the fractions? What's that called when you guys do A over B and then make it B over A? What is that? That's the, okay, they are turned into reciprocals. So the reciprocals are also equal. Very good. So reciprocals are equal. I remember in a particular AP problem that I have with my calc students, they're like, oh, I didn't know you could do that. That you can flip both fractions and it still be an equivalent equation as the original. Okay, so if you work with proportions and you're second guessing, like, can I do that? Just cross multiply and then do I get back to the same cross products as the original? If I do, then it's kind of like, you can think of it as a legal move. So in the example that you guys have there, what is 5a equal to? This is just coming up with equivalent expressions. Can you guys type it into the chat? What is 5a equal to? Okay, they cross multiplied that and they got 3b. Very good. Okay, using the same expression that they have there, this time they put 5 over b is equivalent to blank over blank. So the answer that you guys put as the fraction has to give you guys the same cross product as the original. Okay, so can you guys type into the chat, what do you think 5 over b is equal to? I'm getting a couple things come across. So you want to think what would have to be here such that if I cross multiplied, I would get the same thing as I do here. Okay, so it should be 3. And then same question here. If I were to cross multiply on the other butterfly wing, it would be the same answer as I would get on the original, which is 5a, right? So the a is missing. So 3 over a, very good. So again, just double check your work. When I cross multiply in my mind, is it the same as the original? And it is in that order. Okay, try it again, you guys. What is 5 over 3 equal to then on C? What's the equivalent ratio on the right? Okay, cross-check. The 3 has to match up in the diagonal. The 3 has to match up with the B. The 5, the A. So B over A is the correct answer. Very good. Okay, so can I have you guys try number 1 next? Okay, what is 2x equal to? And it didn't say to solve, it just says what's equivalent to 2x in this example. Okay, perfect. Cross multiply, 28. Okay, 2 is a little bit different. 2 is asking you guys to work backwards now. If you were to write an equivalent proportion for this, this is kind of think of it as this as after you cross multiply, that's your answer. What would it have to be over on the right in order for that to be true? Okay, so if I were to cross multiply, the 3 needs to go with the y. So the y needs to go here, right? Y times 3 is 3y. And then x would have to go with the 2. So 2 y over x is the correct answer. Okay, good. Okay, so now down below here, you're given a figure, and this is not working with similar triangles at all. They're giving you guys a proportion. They're saying AD to CE. Okay, so, AD to DB is equal to CE to EB. So now we just set up the proportion. So if you guys are given CE equals 2, EB equals 6, so these are all parts of the proportion here. AD is 3, find DB. So this is what we don't know. So what I'm going to do is fill in that proportion, just do direct substitution. AD is 3, DB we don't know, and CE is given to me as 2, EB is 6. Okay, a couple of things you guys can do. If you can reduce a fraction on one side of a proportion, go ahead and do that. So 3 over x is equivalent to 1/3. And sometimes that helps with the cross multiplication process. So what is x equal to in this case? I'm seeing quite a few ones in the answer. I'm not sure how you guys are getting that. So if you are cross multiplying, 1 times x is x, 3 times 3 is 9. So there's actually no equation to solve for. X is equal to 9, and they asked what x was, so dB is equal to 9. Is there any questions? I'm not sure how some of you guys got 1 as your answer for that. Are we doing okay? Okay, sometimes they might not give you guys all the information that you would expect like they did in the previous problem. So in this next one, they tell you that AB, which is this entire segment, is 10, DB is 8, and CB is 7.5, whereas they're asking us to find what EB is equal to. So we don't know what that is. Okay, so a couple of things. They did tell us that our proportions are about the parts, like this part to this part, this part to this part. Okay, so first of all, can we figure out what AD is equal to? If I know that the whole thing is 10 and this piece is 8, what is AD equal to? Okay, good. We do a simple subtraction, right? 10 minus 8 is 2. So this is 2 here. So even though it wasn't given to me, I can figure that out. Over on the other side, we're going to say we don't know the pieces, and we're given information about the pieces. So what we're going to do is redefine this so that we introduce a variable. We don't know what this is, so this is x. Okay, using the same strategy you guys just did, what would be an expression for EB? In terms of what you guys have there, what's an expression for EB? If CE is x, what is EB equal to? Okay, if the whole thing is 7.5, you guys, if the whole thing is 7.5, right, and this is x, very good. Then EB is the difference between the two. So the expression would be 7.5 minus x. Very nice. So 7.5 minus x. I'm going to stop and pause. Does anyone have any questions on that so far? So we need to come up with expressions for unknowns, right? We don't know that they're equivalent. Cody, we don't know that these are parallel to each other. I suppose they're just given as the proportion. We're working with that proportion that's given to us. We don't necessarily know it's 2. Yeah. All right, so working with that proportion that was given at the start of 3, AD is 2. Okay, DB is 8. And then on the other side of the proportion, CE is x. And EB is 7.5 minus x. Now I notice that I can reduce the 2 8s, so I'm going to go ahead and do that first. So that might help me in my calculation. So 2 8s is 1/4. And then cross multiply from there. You guys have 4x is equal to 7.5 minus x plus an x on both sides. So 5x equals 7.5. Divide through by 5. Okay, you can't have, and I don't know when it is that, actually, can you guys tell me if a math teacher before told you guys you can't have a decimal inside a fraction? Has anyone ever told you guys that? Like that this isn't simplified? Do you guys know that? I always wonder, like, at what point are you told those things? So this is not considered simplified if you have a decimal within a fraction. So what we have to do is just make sure that it's just a fraction in simplified form. So 7.5, if you guys forgot how to convert 7.5 to an improper fraction, it's 7 times 2 plus 1. So what is that over 2? What's 7.5 as a fraction? Okay, good. So 7 times 2 is 14, plus the 1 is 15. So that's 15 over 2. Divide by 5 is the same thing as multiply by the reciprocal, so multiply by 1/5. So do you guys remember keep, change, flip? You keep the top, you change the division to multiplication, and then you flip the bottom. And if the bottom is 5/1, you're going to flip it to make it 1/5. The 5 can be reduced with the 15. So your final answer is EB is not 1.5, right? X, what we solved for was 1.5. So what does EB equal to? If CE is 1.5, what is EB equal to? Good, it should be the difference between 7.5 minus 1.5, which is your X. So if you guys subtract the 2, you should get 6 is your correct answer. All right, you guys, so I think I'm going to stop with just one other comment that is going to lead into the project, and that's going to give you guys about half an hour to figure and send me a remind and figure out the meme. Is what you're going to do is you're going to scale an object. And so we're going to move into this chapter is about similar figures, including polygons. For you guys, whatever your meme is, similarity just means that there's 2 things that are true. Okay, all angles are congruent when you're talking about 2 figures that are similar. So when you guys are sketching your meme, you're going to make sure that the angle measures are all congruent. If it happens to be shapes that you guys are sketching, that remember that you're maintaining the same size and shape, or sorry, same shape, but the size is different. Okay, congruence was same size and shape. So corresponding angles, that is one of the parts of similarity that students always forget. Of course, all the angles have to be congruent. Okay, it's the sides that are in proportion. So you change the measures of the sides. Okay, and the scale factor, which you also have to decide on today, is how you guys want the sides of, let's say, your object or your meme to grow by. So if you initially have something that is 3 by 3 and you want to triple it, then your new one should be 9 by 9. Okay, so the scale factor is a ratio of your corresponding sides. So for a scale factor, you guys are thinking of, if I say, for example, if I say my scale factor is 1 to 2, then that means that I'm going to go from an object that is a particular size and doubling that. So the 2 means that you're going to double the size of it. Okay, so if I say 1 to 3, I would expect that original image to then be tripled in size. Okay, one way to label your vertices is in geometry. If you guys have, like, for example, let's go ahead and label the vertices. Like, this is A, B, C, D, E. The vertices are the corner. Then your new figure is going to be written with a notation called prime. So like A prime. And we did this with transformation. So A prime, B prime. So the primes are like your new figures after you guys have transformed it. Either transformed it, or in this case, you guys are enlarging or shrinking it. Okay, and you would read that as A prime.